Now let's move on into section 1.2, where we're going to look at different kinds of estimations using graphs, mathematical modeling, and another technique that you're probably pretty familiar with called rounding. Let's start with the general idea of estimation, which I'm pretty sure all of you guys are familiar with. Where all estimation refers to is the process of finding approximate solutions or approximation. Where, notationally, we say two values are approximately equal using the symbol of the wavy equal sign. It looks sort of like two tildes instead of two straight lines for an equal sign. We'll see exactly what that means when we start talking about some examples. Start looking at how this is used. That's what we're going to be talking about with this section, is making estimations. Let's start with the most basic form of estimation, rounding. To talk about rounding, I first need to talk a little bit about numbers. So, like I said in section 1.1, the numbers that we work with every day are counting numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to infinity, are what are called the natural. There are natural counting numbers, and if we include 0 in that, we get the whole numbers, and then for reference, if we include the negatives as well, we get what are called the integers. But mostly, we're going to be focusing on the natural numbers for now, where we call each of those values, those single digits. I kind of gave away the idea there. But anyway, for rounding whole numbers, we have a simple two-step process. First thing we do is we look at the digit to the right of where our rounding is to occur. We look to the right of the rounding digit. Then we have two options. Our first option, option 2A, is if the digit is 5 or above, let's say 5 plus for that, add 1 to the digit to its left, replace all the digits to the right with 0. Now that I'm writing it out, this is going to make rounding seem more complicated than it is. Trust me, it's not actually that bad. And our other option is if the digit is less than 5, you just replace it and all to the right with 0. So like I said, this is something you've probably done before. Let's do some really basic examples to get started. Let's say round 17 to the nearest 10. When we're saying round to the nearest 10, That means we're rounding to this digit, rounding to the second digit, I guess you could say second from the right. So that means we're going to be looking at this one, where the 7 is greater than 5. We get 20, because we took that 7, since it's greater than 5, added 1, the digit to its left, replaced everything else with zeros. Everything else was just 7, which we can say is approximately equal to 17. That's how we use that approximation sign. Similarly, if we wanted to round, let's say, 1,426 to the nearest 100, what we would do is look at this and say that since we're rounding to the nearest 100, we're looking at the tens digit. And since 2 is less than 5, this whole thing gets rounded down. So we get a 1. We didn't do anything to the thousands digit. Since it's less, the 4 stays, nothing happens to it. And that 2 gets rounded down to a 0, as does the 6. So, to the nearest 100, 1400 is approximately equal 1426. Let's do one more quick example, then we'll see how we can actually use this meaningfully. Let's round, say, 1.78 the nearest digit. Here, we're rounding 1.78 to the nearest digit. I'm going to be a little shorthanded. Since we have that 7 is greater than 5, we're going to knock off these two. Those will both become zeros. And we're going to add 1, the left digit, the digits place, and get that 2 is approximately equal to 1.78. But remember, when we're talking about decimals, we kind of flip the notation. So this would be called the tenths digit. This is the hundredths digit. Go further down, you get the thousandths, 10 thousandths, 100 thousandths, millionths, and so on.